2. Introduction. All the organisms living on Earth interact and modify their environment without causing any damage. However, human interference with the environment causes significant damage to the system. Increase in the human population and development of new technologies have created tremendous scope of modification of the environment. When the human shifted his habit to agriculture from hunting, even then his dependency on the primary productivity was not changed. Instead of depending on the productivity of natural ecosystems, now humans start depending on the productivity of the maintained agricultural ecosystems in terms of food resources. As a result, permanent villages were formed, which further leads to division of labor and development of new social structure. The transition to agricultural society greatly eased the environmental constraints imposed on human carrying capacity. However, the continued dependence on plants and animals as the sole source of energy still set an upper limit on the productivity of human activities. In 18th century, development of the technologies replaced manual work of human and animals by machines, which lead to industrial revolution or industrialization. A transition was formed during 20th century from rural agricultural-based economy to an urban industrial-based economy that shifted the distribution of human population. At the beginning of 20th century, only 35% human population lived in urban area, and it increased further up to 80% in the early 21st century and continues to grow. The increased population required more food, space and other resources. Due to increased population, we utilize more than 50% resources of freshwater, of which 70% of resources utilized in agriculture. We utilize 40% to 50% of the land surface for the production of food, fiber and fuel. The exploitation of these natural resources to fulfill the basic needs of growing human population led to the extinction of large number of species. Initially, the long-term consequences of human activities on the environment were not realized, but in 1970s, the mantra was, the solution to pollution is dilution. Sustainability is an idea burdened by ambiguity. The concept of environmental sustainability is based on harvesting the natural resources without diminishing them or undermining their long-term ability to regenerate. In other words, sustainable resource use is controlled by supply and consumption. In Figure 1, the box represents the resource and the arrow moving into the box represents the rate of resource supplied to the system, and the arrow moving out of the box represents the resource utilized. Figure point 1. A simple model of resource use. Figure point 2. Rate of resource availability when used sustainably or when resource is exploited. Output. Consumption rate. Q. OTN. T. FO. R. SE. UO. CRE. VA. IA. AL. LB. E. OF. R. SUE. Time. Output less than input. Output equals input. Output greater than input. Max. However, if the rate of resource utilization does not exceed the rate of replacement of resource, it is said to sustainable. However, if rate of utilization exceeds the resource replacement, the resources are said to be exploited and the quantity of resources declines for next generation. Figure 2. The sustainable resource utilization assumes that the used resource is renewable, which can be regenerated by nature itself. If the resource is non-renewable, it cannot be termed as sustainable, and its decline depends upon the rates at which it is consumed. For example, aluminum, iron, copper and zinc are non-renewable resources. However, some of the resources which can be regenerated are also classified as non-renewable because their resupply rate is almost non-existent when compared to their utilization rate. For example, coal, petroleum, and natural gas required millions of years for their formation, and its resupply is zero on the timescale of human consumption. 3. Sustainability versus natural ecosystems. The concept of resource utilization through sustainability can be better clarified by studying the ecological concept of functioning of natural ecosystem. The ecosystem is the functional unit of ecology, which is defined as the self-sustaining system where resource formed by the producers are utilized by the consumers, and when they die, the resource is recycled by detritivores and again available to the producers. For example, uptake of nitrogen by plants is forced by the rate at which they become available in the soil. The nitrogen is utilized by the plants for the synthesis of organic matter, biomass, which is consumed by herbivores, which in turn are eaten by carnivores. Finally, nutrients tied up in organic matter are recycled by the processes of decomposition and mineralization. As nutrients are converted into simpler forms and returned to the soil, they are rapidly absorbed by plants to minimize their loss through different means: ground and surface water. The human population explosion and its activities on the environment and natural resources are adversely affecting them. The human population has grown from 600 million in the year 1760 to 6.3 billion in the year 2003. The human population size has doubled in the last 40 years. It may further increase to 9 billion by 2050. Cohen 2003. Human and their interference in the nature for getting food, space, industrial development, energy and urbanization are affecting the earth at various scales ranging from local region to globally. It causes the degradation of natural resources and threatened biodiversity on the earth. Sustainable development stressed that the rate at which natural resources are consumed must approximate the rate at which the resources are regenerated. At the same time, the resource must fulfill the social, economic and other needs without affecting the needs of the future generations. The purpose of sustainable development is to balance between ecology and economics and manage resources of human use. Thus, the sustainability has become key concept in fate of the Earth system, i.e. biodiversity, ecosystem, goods and services as well as human being. 4. Causes of unsustainability. The causes of unsustainable development are increased human population and overexploitation of natural resources like trees, water, air and habitat. Environment degradation refers to diminishing of ecosystem at global or local level due to human activities. Environmental degradation, when occurs for longer duration, leads to collapsing of ecosystem as a whole, which will no longer be able to sustain human population. The unsustainability increases when the sum total of natural resources, natural capital, is utilized much faster than it can regenerate. In the developing countries, the natural resources are exploited to fulfill the basic needs food, shelter, fuel and wood of the population. The various activities performed by human are actually done to improve the quality of human life, which is usually associated with environmental degradation. The various human activities include intensive agriculture, which hasten deforestation, desertification and reduction of genetic diversity. Pollution of air, water and land also become a challenge, which is directly associated with the human health. Inland water bodies and coastal area became the dumping ground for disposing wastes generated by human, which adversely affect the aquatic and marine life. Other activities such as overfishing, excessive consumption of fresh water, deforestation and industrialization also accelerate the process of environmental degradation and social disintegration. The fast escalating revolution is the result of human greed, which unfortunately leads to the exploitation of natural resources. Excessive dependence of agriculture on chemical insecticide and fertilizers also helped in the environmental degradation. The increased demand of land, fresh water, marine and coastal resources resulting from expansion of agriculture and uncontrolled urbanization led to degradation of natural ecosystem and eroded the life-supporting system. Caring for natural resources and promoting their sustainable use ensures the survival and well-being of living communities. 5. Challenges in sustainable development. There are numerous challenges for achieving sustainable development. The main threats are economic disparity, political instability, severe poverty, disease, undernourishment and disease, population growth and high consumerism in developed economies and increasing global use. The populations of the 47 least developed countries exist on less than 0.5% of the world income. More than 2 billion people do not have access to adequate sanitation, 1 billion people do not have access to clean water and 1.3 billion people are breathing air below the quality set by WHO. Poverty and socioeconomic inequality also become serious issue of sustainability regarding peace and security, equity and solidarity and the environment protection at the national, regional and global level. High poverty rate are linked with various social evils like disease, family breakdown, endemic crime and use of narcotic drugs. Presently, global food production is adequate to fulfill the nutritional requirement of human population, but due to inadequate distribution of economic resources and foodstuffs, around 800 million people remain undernourished. AIDS and malaria are two serious diseases which influence the productive capacity of people. Environmental pollution, global climate change, natural resource deterioration and loss of biological diversity has complex interactions with socio-economic systems. Priority atmospheric issues include climate change, stratospheric ozone depletion, acidification, urban air quality and tropospheric ozone levels. The impact of these issues relate to human health, biodiversity and the health of ecosystems, an increase in extreme events, economic damage due to adverse effect of agriculture, forestry and fisheries, and many of the effect are long-term, global in nature and irreversible with consequences for future generations. 6. Sustainability indicators. Indicators are defined as something that reveal or detect and is a simple statistical figure that helps to compress information into an easily understandable form that can facilitate the decision-making process. It can be used to measure progress towards sustainable development as well as provide an effective means of communicating ideas, thoughts and values. The Commission on Sustainable Development, CSD, 1995, provided a working list of 134 indicators and the related methodologies. In 2001, CSD developed the final framework of 15 themes and 38 sub-themes in which emphasis was given to use these indicators in decision-making processes at national level. In 2003, CSD reaffirmed the importance of indicators for sustainable development. An attempt of composite sustainability index was commissioned by the Indian former Minister of Environment and Forests Jairam Ramesh CSTEP 2011, but the draft does not include several issues and factors listed above. Another attempt was to propose a composite sustainability index for preliminary analysis in India to understand how various states in India are faring. Roy and Chatterjee 2009, but it also overlooks a number of important parameters. Substantially more work is required to develop a set of indexes that is robust, relatively easy to calculate, open to public understanding and participation, and capable of integrating complexity and nuances. There are a number of works being done outside India, such as Happy Planet Index proposed by the New Economics Foundation (NEF 2012) and Bhutan's Gross National Happiness that could be assessed for their suitability. Others Environment Sustainability Index includes Green GDP or ANDP, Environmentally Adjusted Net Domestic Product, and Adjusted Net Savings, but these have various limitations as standalone measures. Stiglitz et al. 2009. Another is the Environment Vulnerability Index, which includes 50 sustainability indicators related to weather, geography, biodiversity, natural resources and human activities. Some of the indicators relating to atmosphere, land, oceans, seas, coasts, freshwater and biodiversity are briefly described as under. 6.1. Ecological footprint. It was proposed by Mathis Wackernagel and William Rees in 1990 at the University of British, who propagated worldwide the Global Footprint Network. Ecological footprint is the total amount of biologically productive land and water which is needed in a particular country or area to provide indefinite supply of renewable resources and recycle the wastes produced by such resources. About 25% of the Earth's surface is biologically productive, which supports most of biomass production. The ecological footprint compares consumption of renewable resource with capacity of biological productivity on a global scale. WWF 2002. In 2008, WWF and Global Footprint Network estimated that humanity's global ecological footprint exceeded the Earth's biological capacity to support human and other life forms indefinitely by at least 30%. The ecological footprint of developed countries is more due to their huge consumption of renewable resources. According to WWF, we need roughly the equivalent of at least 1.3 Earths to provide indefinite supply of renewable resources at their current average rate of use per person and disposal of the wastes generated. The changes in population size, consumption rate and technology can either narrow or widen the gap between human footprint and biological capacity. 6.2. Carbon footprints. It is the measure of greenhouse gas GHG emissions that are directly or indirectly caused by an activity or accumulate over the life stages of a product or service, expressed in CO2 equivalents. According to IPCC Intergovernmental Panel on Climate Change, there are 18 greenhouse gases with different global warming potential. However, according to United Nations Framework Convention on Climate Change UNFCCC, 1997, and its Kyoto Protocol, only few gases such as CO2, CH4, N2O, hydrofluorocarbons HFCs, perfluorocarbons PFCs, and SO2 are considered for the purpose of carbon accounting. As a single parameter, it is useful to gauge some aspects of sustainability, though this will not cover all aspects. 6.3. Atmosphere. Agenda 21 suggests an integrated approach to protection of the atmosphere, coordinated with social and economic development, which focuses on I. Improving the scientific basis for addressing uncertainties. E. Preventing stratospheric ozone depletion. E. Addressing transboundary air pollution. IV. Promoting more sustainable and efficient energy use, transportation, consumption, industrial development, and land and marine resource use. 6.4. Land. The land in the CSD framework mainly focuses on the sub-themes of forests, agriculture, urbanization, and desertification. The selected indicators are relevant for assessing sustainable development at the national level and are generally supported by appropriate data sets. The indicators from other environmental sub-themes complement these measures of land sustainability, for example, ecosystem water quality, climate change, and coastal zones. In addition, pressure on land and land use are reflected in social, economic, and institutional themes, such as poverty, drinking water, population change and energy use, and natural disaster preparedness and response. 6.5. Oceans, seas, and coasts. The CSD core sets include 3 indicators under the sub-theme of coastal zone and fisheries that are national in scope and within the capabilities of most countries to develop. The total population in coastal area and algae concentration in coastal water provides measures of overall pressure on the coastal resource, particularly from land-based activities. The annual catch by major species provides a core indicator where data is generally available to measure the intensity of fishery activity. In terms of key marine ecosystem, such as coral, mangrove, and seagrass, countries may wish to consider trends in the extent of these areas under biodiversity ecosystem sub-theme. 6.6. Freshwater. The freshwater indicators in the core set capture the 2 essential dimensions of quantity and quality. The amount of available water utilized by the people of a country and demand for water causes water shortage. The measurement of biological oxygen demand and fecal coliform concentration reflects the health of ecosystem as well as human health. These indicators are policy relevant and generally measurable at the national level. 6.7. Biodiversity. The selected biodiversity indicators measure the area of selected key ecosystem, the abundance of selected key species, and the protected areas as a % of total area. They are relatively easy to calculate, meaningful to decision maker, and allows countries flexibility in determining the most important ecosystem and species from a national perspective. The Ministry of Environment and Forest, India also included some human development indicators such as infant mortality rate, life expectancy at birth, and adult literacy rate better suited to Indian conditions in addition to those of the UN list. 7. Sustainable Development, New Paradigm. The World Commission on Environment and Development 1987 first addressed the problem of conflicts between environment and development goals by formulating the Sustainable Development. On the basis of their report, Our Common Future, there is 3 aspects of sustainable development. Figure 3. 7.1. The economic perspective. An economically sustainable system should produce goods and services on a regular basis without causing any damage to the system. According to neoclassical economic theory, sustainability is defined in terms of the maximization of human welfare over time. Most economists explain it by identifying the maximization of welfare with the maximization of utility derived from consumption. While this is criticized due to its oversimplification, it certainly includes many important elements of human welfare such as food, clothing, housing, health, transportation, and education services. Standard economic theory explains that the efficient resource allocation could affect the maximizing utility from consumption. When we consider soil erosion or accumulation of greenhouse gases in the atmosphere which had damaging impacts over several decades or generations, formed a strong bias against sustainability. So, to attain intergenerational equity, it should either inflict a low discount rate or certain sustainability rule concerning resource use and environmental impacts. Soils and atmospheric functions are aspects of natural capital, which consists of all natural resources and environmental services present on the earth. According to Herman Daly, sustainable development can be operationalized by conservation of natural capital. This policy goal leads to 2 decisions, one for renewable resource and other for non-renewable resources. For renewable, the rule is to limit resource consumption to sustainable yield levels, and for non-renewable resource, the rule is to reinvest the proceeds from non-renewable resource utilization into investment in renewable natural capital. The rules will help in maintaining constant stocks of natural capital, but it need to maintain a stable human population. Economic development. Ecological development. Social development. Sustainable development. Social. Economic development. Conservation. Deep ecology. Figure point 3. The interaction between economic, social, and ecological development. 7.2. The ecological perspective. Unlike economists, whose models does not provide upper boundary on economic growth, ecologists are adapted to idea of limits. Natural systems must exist subject to unyielding laws of thermodynamics, whereas population ecology has explored the inference of these laws for living organisms. The 2 fundamental facts of ecological and evolutionary biology is that the organisms show over reproduction, but their limit is set by space, time, and energy. From ecological point of view, sustainability must involve limits on population size and consumption levels, which is applicable to all biological systems. Paul Ehrlich and colleagues have estimated that humans are consuming or eliminating about 40% of energy supply for all terrestrial animals. Moreover, doubling of this demand will be implied by a 33% growth in population to 8 billion and a 50% growth in per capita consumption by 2050. This increase in demand would decrease the chances for any other species to survive on the Earth. However, this declaration of limits by ecologists does not fully capture concept of sustainability. Holling identified a third axiom of ecology that generates genetic variability and novelty, which causes the process of evolution and change in species and ecosystems. Genetic diversity provides resilience in ecosystems. Resilience is the bounce back capacity which makes the system to respond to disturbances and damage. For example, if a forest is infested by pests, then it can recover from a pest infestation either by increasing predator population or possibly by development of pest resistance in affected species to control pest population. The patterns of response can vary, but the essential integrity of the ecosystem will be preserved. The key to resilience is the existence of a large number of different species which interact with each other in a system and provide reservoir of different genetic forms. These different forms provide the potential to adapt to changing conditions of the system. Sustainability in terms of ecology can be defined as the maintenance of ecosystem resilience. This view of sustainability is different from the human-biased concept put forward by the World Commission on Environment and Development and the consumption-based principles from economic theorists. For achieving ecological sustainability, it is necessary to modify current production techniques and consumption preferences which are efficient in economic terms but threaten the ecological resilience of the system. The importance of the ecological perspective is continuously increasing because most of the critical problems faced by humans arise due to failures of ecological resilience. The resurgence of diseases due to resistance from antibiotic, disruption of ecosystems by introduction of alien species, formation of dead zones in coastal waters, and various ecological threats caused by climate change and increased climate volatility. All these disturbances occurs due to the impacts of expanding human economic activity. The deadly impact of AIDS, especially on the African continent, is the worst example of destruction of ecosystem resilience by humans. It probably originated in primates, living in the rainforest, and started infecting humans as their intrusion starts into the forest. Instead of remaining isolated in small communities, it spread worldwide through global commerce and travel, like many other pests and disease-causing viruses. So, an ecological economic approach is required to allocate the resource in such a manner that they neither threaten the complete system nor the components of the system. Environment system must maintain a stable resource by avoiding overexploitation of renewable resource and depleting non-renewable resources only to the extent that investment is made in sufficient substitutes. It includes maintenance of biodiversity, atmospheric stability, and different ecosystem functions not usually classed as economic resources. So, an integration of economics and ecology is required that can be achieved only with the assistance of the third element of the sustainability called the social perspective. It is the social area where we must look for the key to formulate policies for sustainable development. 7.3. The social perspective. It recognizes the social component of development as an essential part in sustainability. Human development emphasizes the issues of basic needs and equity in the history of economic theory. In the 1997 report UNDP Human Development Report, a section on resisting new forces of poverty discussed various factors that have been responsible for worsening conditions of poor people in the world. One of the worst pandemic is HIV/AIDS, which has created a wave of impoverishment and had reversed the earlier gains. Another factor is environmental degradation on marginal lands such as dry, saline, swampy, and steep areas where most of the rural poor struggles for survival. Hence, issue of environmental sustainability is associated with poverty and inequity. It has been noted that the increased poverty and loss of rural livelihoods has increased the process of environmental degradation. As a result, the displaced people generated more pressure on fisheries, forests, and marginal lands. Therefore, socially sustainable system can only be achieved through distributional equity, adequate provision of social services including health and education, gender equity, as well as political accountability and participation. 8. Guiding principles of sustainable development. Sustainable development is a global concept, and the preconditions for sustainable development are equity and social justice, economic efficiency, and ecological harmony. The main agenda for sustainable development has a focus on carrying capacity-based sustainable development, structural change in the economic sector, and preservative environmental planning. Conservation-based developments need to protect the structure and function as well as diversity of natural ecosystems with a focus on following aspects. 1. To conserve life-supporting system and ecological processes. 2. To conserve biological diversity in terrestrial, freshwater, and marine system. 3. Sustainable use of resources. 4. Minimizing depletion of natural resources. 5. To care for the environment and poor in South. 6. Not to exceed the earth carrying capacity. 7. To improve the quality of life including social and economic concerns. 8. To develop a national framework code to integrate development and conservation. In ecological perspectives, sustainability must involve limit on population and consumption levels, as humans are now using, co-opting or eliminating, some 40% of the net primary productivity of all terrestrial ecosystem, Vidisek et al., 1986.